All right, today we're going to look at the first two examples of rational graphs, section 2.6. And so hopefully you have downloaded the characteristics of rational functions from the home page. And you'll want to print this. This is going to be a great resource for you as you're doing your homework. So it's this page, it's the back, and then a third page. So make sure you have that, and I'll step you through all these steps as we go along. So this is really important that you have this downloaded and printed out. So the first thing we're going to do is we're going to find the domain. So we'll go back to our characteristics, and it'll say factor the denominator. And so I look here, I have x minus 1, so it doesn't need to be factored because that doesn't factor any further. And then it says set each factor with an x in it equal to 0 and solve for x. So I'm going to go ahead and do that. I have x minus 1 equals 0, and I'll solve for x, and I get 1. So then we're going to state the domain in this notation. So this stands for x such that x does not equal, and then whatever values you get from that denominator. So x such that x does not equal 1. And what that means is if x is 1, I'll have 1 minus 1, which is 0, and I'll have a 0 in the denominator, and we all know that we can't divide by 0. The next thing we're going to talk about is a whole. So a whole comes from when you have a common factor in the numerator and the denominator. So if I look at my numerator and I factor that, which it doesn't factor, these are not common factors. So this particular graph does not have a whole. So we'll put no whole. And then we go to vertical asymptotes. Vertical asymptotes come from factors of the denominator that are not factors of the numerator. So if you did have a common factor, you would not use that factor. So only unique factors of the denominator. We're going to set that equal to 0 and solve. So we did that here because this is the vertical asymptotes come from the denominator. So I set that equal to 0. So I have a vertical asymptote at x equals 1. Then we're going to look at my horizontal asymptote, and that's on the back here. And so you either have a horizontal asymptote or you have a slant asymptote. And how you know whether you have a horizontal or a slant is you look at the degree of the numerator versus the denominator. So if the degree of the numerator is equal to the degree of the denominator, your horizontal asymptote will be y equals whatever the leading coefficient of the numerator is divided by the leading coefficient of the denominator. And we'll state that as y equals whatever that is, like 2 divided by 1 or 3 divided by 4 as a vertical line, y equals 3/4 or y equals 3. If the degree of the numerator is less than the degree of the denominator, then it defaults to y equals 0 or the x-axis. If the degree of the numerator is greater than the degree of the denominator, then we're going to have a slant or oblique asymptote, and you'll actually have to divide the numerator by the denominator, either by using synthetic division or long division to get that slant asymptote. So let's look here. The degree of the numerator is 1, because this x has a power of 1. That's the highest power of x. This has a degree of 1, so the numerator and the denominator have the same degree. So they have the same degree. It's equal to leading coefficient over leading coefficient. So that's going to equal y equals the leading coefficient here is 1. Leading coefficient here is 1. 1 divided by 1 is 1. So since it has a horizontal, it doesn't have a slant asymptote. Back to the front, the x-intercepts. We factor the numerator, can't be factored. All the factors of the numerator that are not factors of the denominator. So x plus 1 is a factor of the numerator that's not a factor of the denominator. So I set that equal to 0. So x plus 1 equals 0 and solve for x. So x equals negative 1. So my x-intercept is negative 1, 0. My y-intercept, we find the y-intercept by always letting x be 0. So I come back here. So I have 0 plus 1 is 1. 0 minus 1 is negative 1. So I get negative 1. So your y-intercept is 0, negative 1. So that now I've found all my information. So you're going to use your graphing calculator to help you with this. So I'm going to grab my graphing calculator. I'm going to turn it on. Y equals, I'm going to clear this. The first thing I'm going to do is I'm going to graph everything I already know. So I'm going to use this blue pen for my asymptotes. I have a vertical asymptote at x equals 1. And I have a horizontal asymptote at y equals 1. So I have kind of divided my graph into 4 regions. And this is kind of how it works. If you have something here on your graph, you're going to also have something in this region of your graph. If you have something here on your graph, you're going to also have something here. So you're going to either have graphing things here and here or here and here, not all 4. So then we also know we have these 2 points. I'll do this and I'll do that in red. So I've got -1, 0, and 0, -1. So kind of I know I'm going to have something that goes this way. So I'm going to go to my graphing calculator, and I'm going to put in x plus 1 divided by x minus 1. So I'm going to be taking the entire denominator divided by the entire numerator. So if you have the 84 and you want to use the fraction button, that might be easier. But if not, if you have the older one, you're just going to want to put the numerator in parentheses, so x plus 1, divided by, and then in parentheses, x minus 1. And then I'm going to hit graph. So there is my graph, and I'm just going to see, if you see this little chart, it says additional points. I'm just going to go to my table and get some additional points. So let's take a look at things in this region, so where x is less than -1. So I'm going to go up here. So when x is -6, I'm at 0.714. So 1, 2, 3, 4, 5, 6. So right here, 1, 2, 3, 4, 5, 6. And then when x is, I might change my my table set, so I'm going to have 0.5s. So I'm going to go by 0.5 and then go back to my table. I want to see what's happening at 1/2. Positive 1/2. So it's at -0.33. Just so I have I'm sorry, 0.5 is -3. I'm just going to say that doesn't make sense. So right here. So I've got this part of my graph. And then I'm going to look at where x is greater. So at 1.5, I'm at 5. 1, 2, 3, 4, 5. At 3, I'm at 2. And then let's see. At 7, I'm at 1.3. So it just kind of gives me a better sketch of my graph. And if you want, you can put those values in this chart as well. You don't have to, but I do want to see more than the points that you're getting from finding your x and y intercepts. All right, so let's go back to the next one. I like to always say if you can factor numerator and denominator, you're going to want to factor that first. So if I factor this numerator, I get x minus 3, and I get x plus 1, and then down here, x minus 2, x plus 2. I always look for common factors because that tells me I have a whole. In this case, I don't have any common factors, so I know I will not have a whole. So then we can go back to our rational function and finding the domain. Again, when you're finding the domain, you factor the denominator and set all your factors in the denominator that have an x equal to 0 and solve for x. So I've got these two factors. If I set them equal to 0, I get x equals 2 and x equals -2. So that means my domain will be x such that x does not equal 2 and -2. Again, we said there is no whole because there is no common factor in the numerator and the denominator. Vertical asymptotes. Again, the vertical asymptotes come from the denominator. You're looking for unique factors of the denominator that are not part of the numerator. So these two are both unique. We set them already to 0 and solve. So my vertical asymptotes are at x equals 2 and x equals -2. You can always pause this video and look at your kind of cheat sheet, your characteristics of rational functions to see where I'm getting this. I'm kind of going fast, but you can always pause it, look, and see where I'm getting these from. Horizontal asymptote. Okay, so horizontal asymptote, remember that comes, we have to decide what the degree of the numerator is. So the degree of the numerator is 2, the degree of the denominator is 2. So when the degree is equal, if the degree of the numerator is equal to the degree of the denominator, it's y equals leading coefficient over leading coefficient. Leading coefficient here is 1. Leading coefficient here is 1. 1 divided by 1 is 1. So it's y equals 1. So if it has a horizontal, it does not have a slant. X-intercepts, you take the, flip it back over. X-intercepts, that's when you take your unique factors of the numerator. So all the factors of the numerator that are not factors of the denominator produce an x-intercept. You'll set those unique factors to 0 and solve for x, and then we'll write them as ordered pairs. So I'm taking the factors of the numerator and solving for x. So I get x equals 3 and x equals -1. So that means I get -3, 0, -1, 0. And again, my y-intercept comes from when I let all my x's be 0. So if I let all my x's be 0, that's 0 minus 2 times 0 is 0. I get -3. 0 squared is 0 minus 4. -3 over -4. So that means it's 0. Negative divided by a negative is positive. So 0 3/4. All right, so my asymptotes. I have one at x equals -2. +2, y equals 1. And let's take a look at what's going to happen here. I'm going to go ahead and also plot my points that I have. So I've got -3, 0, -1, 0, helps if I x-intercepts are 3, 0. I screwed that up. Most people are like, that does not make sense. Sorry. So it's here 3, 0, 1, 2, 3, 0. And my y-intercept is 0 3/4. All right, so let's go to our graphing calculator. So I'll clear that. I'm going to put the entire numerator in parentheses. Divided by the entire denominator in parentheses. And hit graph. So you can see I have something in this region. I have something down here in this region. And then I have like a little John Travolta in this middle region. So again, I'm going to want to get some more points from my table. So I want to look over here where x is negative. So -9, I'm at 1.2. So -9, so right about here. And then let's see, as we get closer to that x-intercept and negative, that x, the vertical asymptote. So at -3, so 1 to -3, I'm at 2.4. So I've got something like this going on here. And then I want to focus on points between -2 and +2, my x values. So -2.5, I'm at 3.6. Negative, let's see. You can see at -2 I have an error because I have an asymptote. So let's look at -1.5. -1.5, I'm at -1. So right about here. Let's look at when x is +1. So at 0.5, I'm at 1. So it's actually crossing. You can see how this thing in the middle here, this little John Travolta looking thing, is going to cross this horizontal asymptote. So it's possible to cross a horizontal asymptote. It will never cross a vertical. Let's look at 1.5. So at 1.5, I'm at 2. So here's kind of a look at my John Travolta in the middle. And then I'm going to look at points that are greater than 2. So at 2.5, I'm at -0.77. And we know that at 3, we're at 0. That was my x-intercept, my other one. At 5, 1, 2, 3, 4, 5, I'm at 0.57. Let's see as we get further out. Okay, so I'm at 10, I'm at 0.8. So here I've got this going on over here. So that is the first 2 examples. I'll do another video on the back of that. So here's all that information.